1 over a plus 1 over b plus 1 over c equal to 1 over 2 abc are positive integers we want to find. So first, without lots of generality, because the problem is symmetric with respect to abc, we can say a is greater than equal b greater than equal c. And now I want to say that c cannot be greater than 6. So let's check. If c is, for example, at least 7, and because c is the minimum one, we can conclude ABC are at least 7. So 1 over a plus 1 over b plus 1 over c is less than or equal 1 over 7 plus 1 over 7 plus 1 over 7, which is 3 over 7. And we know 1 over a plus 1 over b plus 1 over c equal to 1/2. So we conclude 1 over 2 is less than or equal 3 over 7. Now if we multiply both sides by, let's write, okay, we multiply both sides by 14. So it will be 7 less than or equal 6, which is contradiction. So we can also write this, multiply by 14. 7 is less than or equal 6, which is contradiction. So c cannot be greater than equal 7. C can be what numbers? 1, 2, 3, 4, 5, 6. We should check these 6 numbers. Let's try from first one. If C is 1, we want to reach contradiction for 1 and 2. Let me tell you something. At first, I want to prove that 1 and 2 are not possible. Why? Because 1 over A, suppose that, uh, let's write this. 1 over A plus 1 over B plus 1 over C. Because 1 over A and B are positive, it will be greater than 1 over C, and it is 1 over 2. So if you multiply both sides by 2c, then c will be greater than 2. So we conclude c cannot be 1 and 2. So c is at least 3. Also, we prove c is not greater than equal 7. So c is at most 6. So we conclude c is at most 6. C is at least 3. So we should check 3, 4, 5, 6. So let's start from C3. 1 over a plus 1 over b plus 1 over c, which is 1 over 3, equal to 1 over 2. Now, 1 over a, if we subtract 1 over 2 from both sides, 1 over a plus 1 over b equal to 1 over 2 minus 1 over... we subtract 1 over 3 from both sides. So it will be 1 over 2 minus 1 over 3, which will be 5 over 6. Now, let's write 1 over a plus 1 over b equal to, let me check, 3 minus 2, 1 over 6. Is 1 over 6, and then we can say AB and B plus A equal to 1 over 6 if we cross multiply AB equal to 6B plus 6A. And in next step, we take all things to left hand side, AB minus 6A minus 6B equal to 0. Now, we use Simon's favorite factoring trick. A minus 6B minus 6 equal to 0 equal to 36. So A equal to the product is 36. So let's check the cases. Because A is at least 3, because C is 3, it is at least negative 3. Also, it is at least negative 3. Because A is greater than equal B, this is greater than equal B. So first thing we can check 36, 1. The next case we can check 82, 18, 2. The next case we can check is 9, 4. And next case 6, 6. Okay, because it's greater than equal this, we don't need to check the rest case. So let me just check 1 to 3, 12. Also, we should check 3, 12. So let me move it here. Or just, so let's write it 3, 12, 4, 9, 6, 6. Okay, they are all cases. Now AB will be 6. They cannot be negative numbers because both of them should be greater than or equal negative 3. If you add 6 to each of them, A42, B7, 22, add by 6, and 24, 8. 16 plus 6, 18, 9, 15, 10, 12, 12. So, for example, let's check this one. 1 over 3 plus 1 over 18 plus 1 over 9. If you use common denominator 18, it will be 6 plus 1 plus 2, which will be 9 over 18, 1 over 2. We will see it works. So A, B are these, and we know C for all cases are 3. So if C is 3, we found 1, 2, 3, 4, 5 answers, and you can consider all rotations, okay? All permutations of these ABCs. So I've checked C3. Now as homework, try to consider C4, 5, and 6. And comment your answers right below this video. If you had questions, send message to my WhatsApp number. Please don't forget to subscribe, turn on the bell, and like the video. Thanks. Bye.